Hello everyone, this is Pouyan, and today I'm talking about Navigation Compose. So what should you expect from this talk? Today, I will start with ranting about type safety and error safety while defining destinations, navigating to destinations, and passing navigation arguments around. Then we're going to take a look at the relationship between navigation and recomposition, what happens when we navigate, how do we deal with navigation side effects, and in the end, we are going to take a look at nested graphs and multiple nav hosts, an actual problem that we had in our own application. But before we start, let me tell you, I'm not here to talk about how to use Navigation Compose. I'm here to show you a few problems that will surface as you add complex use cases with Navigation Compose in your app. So I hope you will find something interesting in this presentation. In any case, you're stuck with me for the next 40 minutes, so enjoy. One more thing before we actually start. I am curious to know how do you navigate in your screens. So there's a QR code here. If you scan this, you will be directed to this website, Slido, and there you see a question. The question is, of course, how do you navigate between your screens? And the options are Navigation Compose, Navigation Component with fragments, Support Fragment Manager and Transaction, and other stuff. So please do scan this QR code and answer to this question, but I gotta tell you, if you're one of the people choosing the option others, you must have a really hard life, because I don't know what else is there to do navigation. So if you choose others, please do feel free to find me after this navigation and tell me about how you do that, because I'm really curious. So I leave this for another 10 seconds here. I leave you with 10 seconds of awkward silence. Yeah, that was a joke, if you're wondering. Okay, that's enough. So let's start. Type safety. What is type safety? Type safety is basically making sure that you're passing the right type of object or the parameter to the method or the class we are using. For Navigation Compose, with version 2.8.0, safe arguments were introduced to provide compile time type safety. What does this mean? So let's take a look at the version before, like 2.7.7 and previous versions. In those versions, declaring composable nodes in our nav host was like this. So we specify a composable, we pass a string root, and specify the argument if we have any, and then specify the type of the arguments. Here it is string, it's not nullable, and there's a default value to it. You can leave it out if you don't want. And then the actual composable screen here. And how do we navigate? Using navcontroller.navigate. Again, passing the same string root and also the argument. So what is wrong with this? There are a few problems with this, in my humble opinion, of course. Some might not find it problems, but the first thing is that having string roots is really error-prone. So imagine that we have a composable like this. We have this root to our screen, /1 argument. Then we navigate using navcontroller.navigate, passing the same root and the data we have. Whenever we want to navigate, we need to basically type the same root, and typing it is error-prone. So some might say, are you like dumb, so why not just put it in a constant and use this constant? Well, yes, you can do that, but why would you in 2024 after all these years of experience with navigation? Why are we going back instead of going forward? And also, take a look at this. If you want to specify an argument here, you need to use these curly brackets. And if you add the name of your argument in a constant, you need to use this $sign. It's really easy to put these curly brackets in front of the $sign, and then your app is going to crash without you noticing what is the problem. It will take you hours to notice, oh, you made this small typo here. So that is the first problem. The second problem is that there's no compile time type checking. So again, when you're navigating, whenever you're passing this argument here, you can pass anything. You can pass an integer, you can pass a string, you can pass a float, and the compiler is not gonna tell you that, oh, you're passing the wrong type. When will you find out? When the code is executed and your app crashes. And what's the exception? The exception is like, oh, sorry, we couldn't find the destination you wanted to go to. It's not saying that, okay, you're passing the wrong type. Again, hard to find the reason why your app is crashing. And the third problem, which is almost a personal rant, it's that there is no character escaping for navigation arguments. Again, if you are navigating and you are passing a profile ID, and your profile ID has something like a slash inside it or a question mark, a nav controller is going to think that you're passing this route here, forward slash the first bit, forward slash the second bit. Actually, you're passing two arguments here. And again, your app is going to crash because you don't have any screen with two arguments. So you need to handle this manually. Okay, so what happened with this 2.8.0 version? Basically, with these safe arguments, declaring a composable in the nav host changes to this. You have the composable extension function again, you specify a type instead of a string root, and then the arguments that we are getting it using this, whatever this is, again specifying the type and our actual composable code. And what is this type that we are specifying? It is actually a serializable data class with some parameters inside it. So to sum up what is added here, what is changed here, the first thing is that serializable objects and classes replace string roots. So you can declare something like this, a serializable class, or if you don't want to pass any data, you can declare a serializable object, and then you can use them when you're declaring your composable node here. So this gives us the advantage of the type-safe arguments, because now when you're navigating, there is no way you pass the wrong type. So instead of passing a string root, you now pass an instance of the data class, and you just pass your data here. So it's almost not possible to pass the wrong type. And the third thing, the third problem that was resolved is that now we can have whatever character we want in our parameters. The serializable annotation is going to handle everything for us. So actually, nothing much changed in the code inside the nav controller and like the navigation component. What is changed is on the surface, because these classes are going to be serialized into some sort of a string later. So what does this mean for us? I mean, it depends who we are. If you're an early user who adapted to Navigation Compose before safe arguments, you look like this, sad and miserable. But after safe args being introduced, you look like this again. Why? Because there is a cost for you, especially if you have some obsession with your code being consistent. As an early user, you need to go back retrospectively and change everything you had. Depending on whether you're a freelancer or you work in a big team or small team, your problems vary, but in general, convincing stakeholders why you need to change the code you recently added is a hassle. There is a cost to the refactoring, like planning the work, developing it, QAing it, whatever. And the last problem is that this version is still beta. But 90% of the libraries in Compose are beta, so we will just leave this out. But for new users, it would be encouraging for them to use Navigation Compose. So that's all about the type safety. Let's get over with it and move to our next section, navigation and recomposition. In this section, we are going to take a look at how navigation is related to recomposition, what composables are recomposed when we navigate, and what we need to look out for when we are navigating. But before we get into the topic, we need a couple of small recaps. So the first reminder is that there is no such a thing as a hidden composable in the UI tree in Compose. A composable is either in the composition or not in the composition. For example, if you had something like this, if show button then composable button, if show button is false, the composable button is not going to be in the UI tree. The reason I'm saying that is that with XML, we had 3 states of visibility: visible, invisible, and gone. If you set something to invisible, the component is still in the UI tree, but not visible. We don't have such a thing in Compose. And the second reminder is that changes to states of composables cause recompositions. Well, that's a no-brainer, but just wanted to mention this. But back to our topic. So when we navigate from one screen to another, a bunch of state changes happen. The navigation itself is a state change. The nav controller's internal state changes. The state of the node we are leaving changes. By the node we are leaving, I mean the screen we are leaving. I mentioned node because we need to have a navigation graph in our minds. And the state of the destination node that we enter also changes. But during these state changes, life cycle of the composables change as well. So for example, when we are navigating forward or navigating away from a screen, the life cycle of the screen we are leaving goes to unpause and then unstop. It's a bit different from how life cycle of fragments change when navigating. Composables have simpler life cycles, basically. And when we are navigating back to the same composable screen, the life cycle goes to uncreate, unstart, and then unresume. Let's take a closer look at the navigating forward part. So when we are leaving a screen, the older screen that we are leaving it leaves the composition because there's no hidden composable in the UI tree. And as well, the new screen that we are entering enters the composition. It is basically added to the composition. And the new navigation state that we are in now needs to be reflected on the whole nav graph. But among these changes to the states and everything being reflected on everywhere, something interesting happens, and that is the older screen we are leaving is recomposed and then disposed. Why I say it is interesting? Because of two reasons. Well, we are leaving this screen, right, but it is still in a backstack. We might come back to it at some point, so why is it being disposed? Why are we getting rid of it? And if we are getting rid of it, why are we recomposing it before getting rid of it? Like, what's the reason? In order to figure that out, we need to take a look at both of them, like at the disposal and the recomposition separately. So let's take a look at the disposal part. Why is the older screen being disposed? Well, as we already mentioned, the older screen must leave the composition because it's not visible anymore. And as a result, all of its resources needs to be cleared out, or in other words, it needs to be disposed. So this is how Compose behaves towards the UI tree. If you're not in the composition, all of your resources is gone. So that's the reason it is being disposed. Pretty easy. But why is it being recomposed before being disposed? That's what the interesting part is happening. So to answer that, we need to take a closer look at our nav host and its composables. So take a deep breath. You might want to need it because we're going a bit deeper in our nav host. So imagine we have something like this. We specify a starting screen, like a starting destination. We are passing the nav controller, and we also declare this composable node, passing a type, the composable code here, whatever, doesn't matter. So let's take a closer look at this composable extension function. This is actually an extension function to the nav graph builder, and it accepts a bunch of parameters that we are interested in one of them, the content. This content is actually the composable code or the composable screen that we are declaring and we want to navigate away from or navigate back to it. But it's not alone here. It is wrapped in a lambda with an object of type nav backstack entry. So let's take a look at this nav backstack entry. What is this? According to the documentation, nav backstack entry is a representation of an entry in the backstack. Well, thank you, documentation. The name already says that. But reading forward, like reading more, it says it also provides lifecycle and the view model store and the save state registry to a node in our nav graph. So basically, if we look at the implementation of this class, it receives a bunch of parameters, which one of them is lifecycle state, basically. So it is controlling the lifecycle of our screens or our nodes while we are navigating. So how does this nav backstack entry work? What it actually does? With every change to the lifecycle and every change to the navigation backstack, this nav backstack entry goes to update the lifecycle of our screens, and it does that using a method called update state. So when we are navigating away from a screen, when its lifecycle goes from unpause to unstop, with every change, it calls this update state, and this update state triggers a recomposition in our node. So to sum it up, whenever a lifecycle change happens in a composable, this nav backstack entry triggers a recomposition. So what we understand here is that the recomposition has nothing to do with the disposal part. Being disposed is how Compose works with UI tree. But this recomposition is how Nav Compose does react towards the state changes to keep the nav graph updated. So nav graph being updated is a separate thing from UI tree being updated. That's why recomposition is happening before the screen is being disposed. Now let's take a look at navigating back. What happens when we navigate back to a screen? When we are navigating back, the screen that we are leaving is disposed again. We already went through it. Then the last screen, like the previous screen that we were in, is retrieved from the back stack, and then it is added to the composition again. So as a result, its lifecycle state must change as well. So it goes to onCreate, and then onStart, and then onResume. Here, when we see onCreate, I mean, okay, it is being recreated, it is being added to the composition. So being added to the composition means that, okay, you're being created from scratch again. It makes sense, but a composable being created from scratch means that all of its side effects are running again. So basically, if you have a launched effect, like this example, it is going to run over and over again when you navigate back and forth. So imagine we have a lazy column or a lazy list, whatever, we are controlling the state using this. Remember lazy list state. A launched effect here with a key index to scroll, and we are scrolling this list to this specific index. So imagine that you enter a screen, this launch effect takes you to the 5th item for any reason, your product needs to do that. Then you play around with this screen, you scroll down to the 10th item, then you tap on the 10th item, you go to another screen, then you press back again. What do you expect? You expect to see the 10th item. But what you actually see is that this launch effect takes you to the 5th item. So you're losing the state of your screen all the time. But what if we use a feature that Nav controller provides for us? And that is using save state and restore state flags. So imagine we are using our navigate method like this, passing this data as the root, and then we have these two flags, save state and restore state. According to the documentation, it is going to save the state of the screen in the backstack, and then it is going to retrieve the state for us. Like it is going to save the last tab that you selected or the scroll position that you were in, but it only works if you don't tweak it using a launched effect. A launched effect is basically going to override these changes. So in this case, it is not going to work. So what should we do? Well, the bad news is that I don't have a specific solution or a technique to tell you, okay, if you do that, these things are not going to happen. But the good news is that I have something for you, and that is you need to change the way you think. Well, that is a general sentence. What does that mean? It really depends on the case that you're dealing with here. For example, for some cases, you need to use view models more than you do. You need to use view models for these kind of operations as much as possible. We all know that view models are immune to config changes. They are also immune to navigation side effects, so they will survive whatever is happening in the navigation. For some cases, you must rethink the way you're structuring your composable screens, and if possible, you must get rid of the side effects in your composable code and move the operations to view model, as long as you're not violating like the business logic and the UI logic being separated. But for some cases, it is inevitable to have these launched effects and side effects inside the screens. For those cases, we need to handle these launched effects manually, basically handle the states manually. For example, in the same example we had the list state and we are scrolling it using a launched effect. We can do something like this. We can add a Boolean state that it is saved using remember savable. Whatever we save using this, it is going to be immune to the navigation changes. And then inside our launched effect, we basically check this Boolean. If it's true, we do whatever we want, and then we set it to false. It's like a latch or a switch, basically. Again, I'm not saying you need to do that. It really depends on the case that you want to do. In some cases, you might want to update the index to scroll so your launched effect takes you to the right position, or sometimes it doesn't work for you. As I say, there are a lot of cases, and you can't map all of them and say, okay, do this, and this is going to work for that. So that is basically it about the relationship between navigation and composition. And as you saw, it is not a healthy relationship. There are a lot of unknowns to it. But before we move into our third act, let's take a look at the results of our poll. So 53 people voted. 40% are using Navigation Compose, which is a surprise to me. I didn't expect that. 40% navigation component using fragments. 30% support fragment manager and transaction, okay. And 13% other. Well, as I said, please feel free to find me after this presentation and tell me about what else you use. To be honest, I'm really curious. And yeah, about this chart, I don't have anything to say about this. Like, I was just curious, but I don't want to analyze it or anything. But okay, I'm surprised by the amount of people that are using Compose, actually. And more people are voting. Okay, it seems like you needed more time scanning the code. Should I stay here or no? I think I'm going to move back to the presentation. So, the last act. Nested graphs versus multiple nav hosts. So what is this part about? Imagine that you have a screen in your app that it has some general capabilities or some general features that you need to use this screen, the same screen, in bigger features in your app. Imagine Instagram, for example. The flow to add a reel or add a post on Instagram are two different things. So you do different stuff when adding a reel or different stuff when adding a post. But there is one common screen shared in both of these flows, and that's add caption. It is basically the same screen, but used in different flows. We also had such a case. We had two flows in our app, one for deleting the account and one for pausing the account. What we wanted to do was that we wanted to add some screens in these flows that ask some questions from the users to figure out why they are doing what they are doing, like why they are deleting the app or pausing the app. When the feature was designed and handed over to us, we noticed that, okay, this screen that we are asking the questions is basically the same in pause and delete. So there's a chance that we can use the same object for it. So in order to have a picture, taking a look at the diagram of this feature, we have an initial screen here. I don't know how much visible it is. We have an initial screen that you can choose pause or delete. I swear it looks better in our app, like my drawing is not good at all. That's why I'm here and not the artist, to be honest. Then, if you choose pause, you will see the first question screen, some question fetched from some remote data source, and then you answer, you go to the second question screen, you answer, you go to the last screen, which is confirm pause account. Again, if you choose delete, you will see the first question screen, you answer second question screen, the question is the same, but the screen is the same, but the questions are different because they are fetched from a data source. And in the end, a screen that you need to confirm that you want to delete your app. So looking at this, we were like, okay, we definitely can use the same screen for the questions, and we see an opportunity to use nested graphs. I mean, not everyone see it that way, but we were a bit crazy, and we were like, okay, nested graphs, why not? We have two flows, and each of these flows can be one nested graph, both of them a part of a bigger graph. So we started the work. We added two nested graphs, one for pause and one for delete, and we created some general nav entries, some general extension functions to be reused in each nav graph. So we added something like this for the first questioner screen, passing some callbacks and extension function to nav graph builder, and declaring this composable node for our nav graph, calling our composable function, which is the actual screen here. And adding another one for the second questioner screen. So we had two screens for questions that you could see one after the other. Again, passing some callbacks, the composable node specified a route, and then calling our actual composable screen. Then we needed to create the nested graphs. So this is the first one for the delete account. We basically passed the nav controller to it. We use this keyword navigation. That's how you declare nested graphs. And then we used the extension function we just created for the first screen, extension function we just created for the second screen, and then the last screen which you confirm you want to delete your account. Then we added the same thing for pause. So navigation keyword, then the first screen, the same extension function, the second screen, the same extension function, and a different screen where you confirm that you want to pause your account. So that's all about the nested graphs. Now we need to call them in our nav host. So in our nav host, we have the first screen where you choose you want to pause or delete, then the delete account nav graph, the nav graph that we just created, and then the nested graph for the pause account. So that's all. That's all we needed to do. Now it's time to test the flows and see what we did. So we started to test the pause flow. We started with this screen, pressing pause. We saw the first question screen, everything is working fine. We answered the question, moving forward. All of a sudden, we ended up in the second question screen from the delete flow. And moving on, we ended up in the last screen from the delete flow, like confirming delete account. We started from pause, but we ended up in delete. We're like, okay, now let's test the delete to see how that is working. Well, testing the delete, choosing delete, we saw the first questions, it was working fine. Then the second questions, working fine, the questions that we were supposed to see. And in the end, the confirm account deletion screen. So the delete flow is working. It's only the pause flow that is not working. So when you see something like this, you're like, okay, we are maybe passing the wrong route to some wrong screen in the pause nested graph. Or we are passing some wrong callback in the pause nested graph. So we went back to our code and we started looking at everything. But after a few hours and a lot of efforts, we were like, okay, everything is fine here. Nothing is wrong with our code. And we were hopeless. So we came up with this crazy idea that, okay, maybe it's not us, maybe it's Navigation Compose. And it was really satisfying because we could blame it on someone else and not take the responsibility for it. But anyway, I started to dig deeper inside Navigation Compose implementation. And this is why it happens. Well, when we initialize a nav host, when we are calling it somewhere in our code, it's not just the nav host and the nodes that we navigate from or navigate to are initialized. The whole graph is initialized in the beginning. So it means for us that when we call nested graphs for pause and delete in our nav host, the whole graph with a bunch of nodes from delete and account are there, and it's not all of them have access to each other basically because they are initialized, they are in the graph, and they are ready to be navigated to. And when we use navcontroller.navigate, what the nav controller does is that it takes the route that we provided to it and goes to this big graph and tries to compare the nodes with each other. And it tries to find the best match with the route that we provided for it. So how does this compare the nodes? Let's take a look at the comparison. It overrides a function called compareTo. Let's see what this compareTo does. Well, it goes through a bunch of stuff. For example, it goes through this is exact deep link. It checks the whole URL and compares them together, apparently. If there is no luck, it goes to the path segments. Segments are, for example, you have an URL with a few slashes and question marks. The segments are each part between these slashes. It goes through them. If no luck, it goes through matching arguments. It checks the arguments in the route. If no luck, it goes to the actions. And if still no result, it goes to compare MIME type match level. What is MIME type match level? It doesn't matter. Why? I will tell you. So this is how Compose compares the nodes with each other, basically. But let's take a look back at our nested graphs. So we have these two nested graphs here, and imagine, let's take a look at the second question screen. So these two, we said they are the same. We are using the same extension function in both nested graphs. The only thing different between these two is their parent nested graph. So basically, the route to these two graphs are different. But what Compose does is that in this compareTo, it is just comparing the features of the nodes specifically and not the features that belong to the parent. And when it does that, of course, there is no guarantee that it returns the node from the right nested graph. So it goes through the whole graph, it reaches the first best match to the route that we provided, and by chance it is from the delete flow while we are in the pause flow. That's why it is returning the wrong node for us, and then we continue with the wrong node to the end of the process. So looking at that, we're like, okay, that's not what we want. We need to create something that each of these flows don't know anything about the other. Basically, when one is alive, the other flow is not in the graph or doesn't exist at all. So we came up with the idea of having multiple nav hosts. What we basically did is that instead of putting the code that we put in nested graphs, we created two different nav hosts, one for pause account, using this nav host class, passing a nav controller, having the first questionnaire screen, then the second questionnaire screen, and with a callback to the confirm pause account screen, and then the final screen of pause. And we did the same thing for delete. We added the first questionnaire screen, which was the same extension function that we used in pause. Then we added the second questionnaire screen with a different callback to the final delete account screen, and then the final delete account screen itself. And where we are initializing the nav host, like where we previously were initializing our nav host, we did something like this. So whenever user chose pause, we check that, okay, if the flow is pause, you initialize this pause account nav host. And whenever user chose delete, you initialize delete account nav host. This way, we only have one nav host alive. There is no way that you have two nav hosts alive at the same time. So all the nodes, they don't know about each other, and we guarantee that the same node is retrieved from the backstack. And that was what solved our problem. So that was basically it about type safety, error safety, recomposition, and like how nested graphs work in Navigation Compose. Well, it might seem a bit of a mishmash of topics inside it, but that's what we experienced with working with Navigation Compose. We spent a lot of time looking at something that was, I don't know, just a misplaced slash or a misplaced question mark, because there's no compile time type checking. So I would say the cost of using Compose for our team, Navigation Compose for our team, was a bit high in the beginning. But we finally, after I would say, I don't know, 2 months, we managed to establish a system for us, and we somehow started to get around the Navigation Compose, and we found out the flaws inside Navigation Compose. And after that, our development was actually faster. But still, with every update, with every major update that Navigation Compose does, it is a hassle to adapt our code with it. But in general, I would recommend you to use it if you're moving to using Jetpack. I mean, I prefer it to having, I don't know, composables in fragments and using Jetpack Compose. But in the end, it is something that depends on you. Like, there is no right choice for that. So it was all from my side about Navigation Compose. In case you want to connect with me or you need the slides, I don't know why you would need the slides, but if you need it, feel free to scan this QR code or simply search my name on LinkedIn, and I would be happy to talk to you about Navigation Compose. That was all from me. Thank you. I'm here for your questions.